So let's find a strategy for these kinds of functions. Number one, if the cosine function has an odd exponent, then what I'm going to do is I'm going to turn all of my cosine squareds into 1 minus sine squared of x. I can even use this in integrals that look like cosine cubed of x times sine of x dx. This is going to become a single cosine times a 1 minus sine squared of x times a sine of x dx. And this is very well set up for a u substitution. Right? It's going to be u equals the sine of x, and a negative du will be equal to a cosine of x dx. Excuse me, yeah. Thinking ahead here. I'm thinking of the next one. Number two. If sine of x has an odd exponent, and implicitly if the cosine function has an even exponent, I'm going to go the other way. I'm going to say sine squared of x's are all going to turn into 1 minus cosine squared of x. And that might look something like, let's say I have cosine squared of x, I have sine cubed of x dx. I'm going to rewrite this as cosine squared of x, 1 minus cosine squared of x. I have a leftover sine of x, and now I can do my u sub, u equals the cosine of x, du equals minus the sine of x dx. And I'll have to move that negative over to the left. That's looking good. My third case scenario is that both sine of x and cosine of x have even powers. This is where I'm going to use the double angle formula. So let's integrate sine squared of x times cosine squared of x dx. Double angle formula tells me that sine squared of x is equal to 1/2 of 1 minus cosine of 2x. The cosine version tells me that cosine squared of x is 1/2 1 plus cosine of 2x. So this integral is going to become, I'll combine those fractions into 1/4. I have 1 minus cosine of 2x. I have 1 plus cosine of 2x dx. I'm going to pull that 1/4 out, and I'm going to multiply this through. So I have 1 minus cosine squared of 2x. Right? 1 times 1, I minus cosine of 2x, a plus cosine of 2x, and minus cosine squared of 2x. Okay. So I'll say that this is 1/4 the integral of 1 dx minus 1/4 the integral of cosine squared 2x dx. And over here is just 1/4 of an x. Right? Super simple. Over here, we're going to need to work a little bit more.